Guys, in this video we are going to see an example of three-phase circuit. Now let's look at this problem right here. This question is asking a positive sequence balanced three-phase Y-connected source with a phase voltage of 120 VRMS supplies power to a balanced Y-connected load. The per phase load impedance is 40 J10 ohm. Determine the line currents in the circuit if VAN is equal to 0 degree. Okay, so here we have the voltage source and also the load impedance. Both of them are in the Y. Okay, so we can go ahead and draw the circuit. This is our Y and this is our Y for the load. Okay, now let's go ahead and draw our voltages. Okay, here we are going to have voltage source, and also here we are going to have voltage source, and in this way we are going to have the load impedance. Okay, and that's it, and we just have to connect this one, and here let's complete this circuit. And this is our circuit. Okay, the question here is to find out the line current. So let's say this is ILA. If this is A, B and C, and here also if this is A, B and C, and here we have the voltage source provided, that is 120 VRMS, and the angle is 0 degree. So this is 120 0 degree, and the impedance is provided, that is 40 J10 omega, 40 J10. Okay, we have this information. Now to find out the current, what we can do is, since both of them are in Y, when we have Y there's no problem. When we have in delta, we have to consider transforming it into Y. Okay, since this is in Y, we are just going to take this part and find out the current. Now we can go ahead and draw the new circuit. In our case we are going to have new circuit. In new circuit we can just draw this voltage source and this impedance, and then we can solve for the current. Okay, let's write our voltage source and then impedance. Okay, so here we are going to have our voltage source, that is 120 0 degree, and then here we are going to have the impedance, that is 40 J10, and we are trying to find the line current ILA. Once you find this ILA, other side, because line current we are going to have three. We are going to have one through this A, then we are going to have this one through this B, ILB, then we are going to have one through this C. But once you find ILA, everything is going to be easy. Okay, to find the ILA, we're just going to do I is equal to VZ, right? V is equal to, no, V is equal to IZ. V is equal to IZ. Therefore, I is equal to V over Z. Since we have the impedance and the voltage, we can directly find out the current. This is ILA. V is 120 0 degree. 120 0 degree divided by the impedance, that is 40 plus 10J. And if you calculate this one, you are going to get 2.91 negative 14 degree ampere. Okay, that's it. Now this is our ILA. Now to find the ILB and ILC, that's very easy. This value doesn't change. The first value doesn't change. The only value that's going to change is the angle. Okay, for this one we always have to subtract 120, and for this one we always have to add 120 with this value, and therefore our ILB is going to be 2. ILB is going to be 2.91, and if you add 120, if you subtract 120 from this one, that's going to give you negative 134. And to find ILC, we add 120 to this angle. This is ILA. We always have to subtract from ILA and add to the ILA. Okay, So here we are going to add to the ILA. In the ILA we have negative 14, and if we add 120, that's going to give us 106 degree. So these are going to be our line currents. Since the question is easy, let's look at the other situations. Like, this is the final answer for this question. Now let's say if they ask for the power. In this kind of question, most likely they will ask for the power, right? If they ask for the power, there are three kind of power you can have. You can have the total active power in three phase, and also you will be asked to find out total reactive power in the three phase, and also you may ask to find out total three phase power delivered by the source. So let's look at each situation. First, let's try to find the total active power. Total active power in three phase. Let's call this one P three phase, and that's going to be, since three phase, we are going to multiply this one with 3, and then we have to take the real part of the impedance, that is 40, then multiply by 40, and after that you pick up the real part of this current, actually the amplitude 2.91, this part, and then you put it square, 2.91 square. This is going to give us the active power, and if you calculate, you are going to get 1016 watts. And if they ask for the reactive power, total reactive power in three phase, that's going to be Q35, and since three phase we have to multiply by 3 times, we have to pick up this imaginary part of this impedance, that is 10. So 10 times, again the current is going to be 2.91 square, and that's going to give us 254 VAR. So this is going to be the reactive power. Now if they ask for the total three phase power delivered by the source, so the power delivered by the source, to find that one, we had to multiply, since this is three phase, right, three phase, we had to multiply this one with 3, then VI conjugate, in our case V is 120, and then I conjugate, I is in the line current, we have ILA, that's the one we are going to deal with, 2.91, and when we convert into conjugate, this one, the sign is going to change, this one is going to be plus 14 degree, okay, plus 14 degree, and if you calculate this one, you're going to get 1016 plus J254 VA, and that's going to be the powers. I hope this helps. Thanks for watching.